Hi again. By the end of this video, you should be able to solve exponential equations by either rewriting them or using inverse operations. Let's talk about what that means. In number 1, you have 25 to the 3x plus 5 equals 125 to the x, and you want to solve for x. This problem is pretty challenging, so before we go off on that, I'm going to take a look at a similar problem if you just had 25 to the 3x plus 5 equals 25. Okay, essentially, the bases of these exponents are exactly the same. So the only thing that you would need to make these equal is that they have the same exponent. Okay, so whatever the exponent is here should be the same as the exponent here. The exponent at 25, if it's not written, is just a 1. So in order for these two things to be equal, all that would need to happen is that 3x plus 5 equals 1. Okay, again, if the two exponents were the same, these expressions would be exactly the same, which would make them equal. Okay, so if you can set this up, now you're essentially solving a linear equation, and then we'll see what happens from there. So subtract the 5 from both sides. You're going to get 3x equals negative 4. Divide by 3, you'll get x equals negative 4/3. And you can double check. If I plug that back in here, 3 times negative 4/3 will give you negative 4 plus 5 will give you 1, and those will be the same. Okay, so you'll have 25 to the first and 25 to the first. Now, the only reason we could do that is because the bases were the same here, so it's easy to compare. So if you have a problem where the bases aren't the same, the first strategy I would recommend is seeing if you can rewrite the bases with a common base. So can I write 125 as 25 to some power? Well, I can't do that, but maybe I can rewrite both bases. So can I rewrite 25 and 125 as a common base? For example, I know that 25 is 5 squared. So can I rewrite this as 5 squared to the 3x plus 5? And 125 is 5 cubed. So I can rewrite this as 5 cubed to the x. Now I have a common base, so if I do a little bit of exponent work, I can compare them. So if you have a power to a power, you always multiply the exponents. So this becomes 5 to the 6x plus 10. And again, you multiply these, which is a little bit easier. It's just 5 to the 3x. And now that I have a common base, I can use what I did over here and continue to solve that. So if the bases are the same, all that has to happen is that the exponents are the same. So I can set 6x plus 10 equal to 3x and solve. So if I move the 3x over, I had 3x. I'll move the 10 over here and get negative 10. Divide both sides by 3, I get x equals negative 10/3. And if I plug that in here, I will get 25 to the 3 times 10/3 is giving me negative 10. So negative 10 plus 5 is gives me negative 5. So I have 25 to the negative 5th, which would then be 1 over 25 to the 5th. And this would be 125 to the negative 10/3. You can plug that in your calculator and confirm those are equal. I'm not actually going to plug that in right now. You can do it on your own, or you can trust me. It's up to you. But x would be negative 10/3. And you can do that because you found a common base. Okay, so what happens if you cannot find a common base? Like I have a 6 here. I can't write that as like 2 to any power. And I'll tell you right now that there's no power of 6 that equals 4,257. You can confirm that in your calculator again. So if I can't write it as a common base, I need another strategy to solve an exponential. And just like if you had 3x equals 6, you divide both sides by 3 because 3 times x, you can undo that with a 3. I take the inverse operation, which is division. You're going to have to solve this by canceling out what you don't want. So like this 6 is bothering the x minus 3, so you have to take the inverse operation to undo that. The inverse operation of an exponential equation is a log, specifically a log with the same base. So the inverse function of 6 to the x would be log 6 of x, which we've proven before. So in order to undo that base of 6, I'm going to take the log base 6 of both sides. And I'll rewrite that because that's a little hard to see. So this is log base 6 of 6 to the x minus 3 equals log base 6 of 4,257. Again, log base 6 of 6 is just 1 because that really says 6 to what power equals 6? And the answer is 1. That's why those cancel out. So you're just left with x minus 3 equals log base 6 of 4,257. To get x alone, you need to get rid of that 3, so I'll just add 3 to that. Actually, sometimes you can write at the end. That's fine, but that kind of looks like you're doing 4,257 plus 3, not the log of that plus 3. So instead I'm going to write the 3 first. So we'll do 3 plus log base 6 of 4,257. If you don't have a calculator, this could be your final answer. If you do have a calculator, you could get a decimal version of this, though. Now, if you can't plug this in your calculator, we know the change of base formula, which says I can take any log I want, so I can just take log base 10 of the argument over the same log of the base, which is 6. And it doesn't have to be the common log. I can also use the natural log. You can really pick whatever you want. And that's the change of base formula. And then I'll add 3 to that and get a decimal. And you can do that on your own. Okay, so if I do ask you to calculate it, you should know the change of base formula. So those are the two methods you'll mostly be using to solve exponentials. There may be some old stuff that comes back in terms of, like, you might have to use the zero product property, or you might have to solve a rational expression, or you might have to add 11 to both sides before you can get rid of the exponential stuff. So in this problem, I might have 5 times 2 to the x equals 70, and then you divide by 5 and get 2 to the x equals 14, which then you'll have to decide, can I write this with a common base, or do I have to take the log of both sides? Okay, does 2 to any power equal 14? I don't know, so you're probably going to have to take a log because this answer is not going to be a whole number. So other things might come up, but the two methods that you've learned are to write with a common base or to take the log or inverse operation of both sides. Now, I just want to reiterate one thing. You cannot multiply these. You have to leave it as 5 times 2 to the x because they do not have a common base. So this is 5 to the first times 2 to the x, which the rule of exponents is if you multiply, you add. But I can't add the x ones because they have different bases. Okay, so just keep that in mind. Or you might have another problem where you have an e, and if you can't find a common base, like is this e to some power? I don't know. You have to undo that e. So I have to take log base e, but remember log base e is just natural log. So that's a couple different types of problems, but essentially you're applying the same ideas. Now for a challenge, here's an exponential equation challenge in disguise. So if you know that you have a 4 to the x, you know this is kind of an exponential equation, you have a 2 to the x minus 5, you may have to get creative with how you rewrite. So I'm not going to take the log of both sides because, whoa, that would be ugly. So maybe I want to use the rewriting with a common base strategy. So I see this has a base of 2, 4, and this kind of has a base of 8. So I see the lowest base of 2. So can I rewrite 4 and 8 in terms of 2? Well, 4 is just 2 squared. That's 2 squared to the x. This can stay the same, and now those two have a common base. But wait, this is an exponent. But let's think about what we learned. Can I write it as an exponent? We know the 4th root of 8 is the same as 8 to the 1/4. So now this looks a lot more exponential, and I can rewrite 8 as 2 to the 3rd to the 1/4. And then I can simplify this to be 2 to the 2x times 2 to the x minus 5. So I do want to say this is an example of a challenge problem you might see. You need to use what I've taught you in terms of the methods and apply it to a problem that's slightly different. Now I'm going to let you finish that challenge in number 4 and number 3. So those are the methods of solving exponential equations, and you should be able to do those on your own. Have a great night.